in, come on in. I'm Mr. Wamsted. This is my house. Okay guys, today all we're gonna do is I'm going to post a video going over the exact same thing I just went over, all right? So the thing I just taught you, I'm posting that video, except I recorded it the other day so that you can watch it if you didn't quite follow, okay? Awesome. Okay, y'all, here it goes. This will also serve as a great review of the coordinate plane. So first off, the parts of the coordinate plane. We're just in the first quadrant right here, okay? Meaning just that L graph. There are parts of the graph that we're not showing. Here is a 4-quadrant plane. We'll do that in a moment. This is just the first quadrant, all right? We have an x-axis going flat and a y-axis going up. Horizontal is x, vertical is y. Notice I kind of stopped counting after a while. 1, 2, 3, 4, 5, 10, 20. Same thing up here, all right? And we have an origin where the x and the y-axis meet. The first thing we're going to do is we're going to count out the coordinates of this shape, this quadrilateral, all right? We count by first going over and then going up from the origin. So if we go 1, 2, 3, 4, 5, 6, 7, 8 over, 1, 2, 3, 4 up, this coordinate is 8, 4. Similarly, this coordinate is still 8 over, but instead of going 4 up, we went 5, 6, 7, 8. So that's 8, 8. This coordinate right here was 4 over and 4 up. And this coordinate right here was 4 over and 10, 11, 12 up. So we've counted out our 4 coordinates. We're almost always going to have to count out coordinates or graph the coordinates ourselves. Remember, first you go over, then you go up. First you go over, then you go up. First you go x, then you go y. Now we're going to do 2 things to this graph. We are going to dilate it by 2, and then we're going to dilate it by 1/2. Dilate it by 2 is like doubling it. It'll get bigger. Dilating by 1/2 is like shrinking it. It'll get smaller. It's really easy to do. When we dilate by 2, all we're going to do is we're going to double the coordinates. So instead of 4, 12, this point right here is going to get dilated to what's double 4, 12? It's 8, 24. This point right here will get doubled to 8, 8. This point right here will get doubled to 16, 16. This point right here will get doubled to 16, 8. Forgot to write 8, 8 right here. And so we have these new coordinates. Let me switch colors, all right, so that we can see it better. All right, so we have this 8, 24 coordinate, the 16, 16 coordinate, the 16, 8 coordinate, and the 8, 8 coordinate. And real quick, if I graph these out, 8, 8 is right here. We've already done 8, 8 once, so it's going to overlap it. There's going to be a blue dot on top of that black dot. 16, 8 is out here. 20, 19, 18. All right. 16, 16 is up here. 10, 11, 12, 13, 14. Again, you may have to do more counting than me. I'm doing it kind of fast. And 8, 24 is way up here past 20. 1, 2, 3, 4. Again, all I did was count over and up with these new blue coordinates. But watch what happens. This is so interesting. When I connect these dots, all right, these blue dots with this blue line, what do I get? I should get the same exact shape. Hold on, let me do it right. But doubled, twice as big. That's kind of cool, all right? So the black shape has turned into the blue shape. it's twice as big. All the lines are twice as big. It has twice the area. All right, I'm sorry, it's got 4 times the area. Actually, it's got twice the perimeter. Okay, super interesting. I'm trying to remember it now if it has twice. Yeah, 4 times the area. Let's make this a red shape. So we've dilated, it's pink, that's the color I found. So we dilated by 2 in blue. All right, we dilated by 2 in blue. And now we're gonna dilate by 1/2 in pink. Let's go back to our original black shape, and instead of doubling it, let's divide by 2. All right? So when I divide by 2, I get 2 comma 2. I divide the top of the x and the y by 2. I get 2 comma 6. Divide the x and the y by 2. I get 4 comma 2. Divide the x and the y by 2. You can get a calculator if you need to. And I get 4 comma 4. Divide the x and the y by 2. No big deal. So now instead of graphing those blue points, I'm going to graph the pink points. Let's do this one first. 2, 2. That's really easy. Over 2, up 2. It's going to get smaller now. This is easy. 2, 6. Over 2, up 6. 4, 2. Over 4, up 2. And 4, 4. Over 4, up 4. Again, it overlaps. It doesn't always have to do that. And I can do this without a ruler. But it does it in this case. Wow! So now you see that that black shape, when I dilated by 2 by doubling it, got twice as big. That pink shape, when I dilated by 1/2 by dividing, got 1/2 as big. So we doubled to get to the big shape, and we did it by 1/2 to get to the small shape. That's pretty cool. You're going to be doing that today too. You're going to be taking a shape and doubling it to make it bigger and dividing by 2 to make it smaller. I'm going to stop this video so I don't have any technical difficulties. All right? And now real quick, we're going to look at a rotation. All right? This will go quicker than the other thing. Again, we have our horizontal x-axis. We have our vertical y-axis. We have the origin where they meet, but now we have all 4 coordinates. And they go like this, 1, and they go counterclockwise, 2, 3, 4. They use Roman numerals for some reason. Again, we're going to graph our points. This is 3 comma 3. This is 6 comma 3. Using pencil in case I mess up. This is 3 comma, I don't know, 4, 5, 6, 7, 8, 9, all right? And now we are going to, where can I write this up here? We are going to rotate this shape 90 degrees, all right? Rotating 90 degrees means it's a quarter turn, all right? You can picture the hands of a clock going to 3 o'clock, all right? So instead of, I'm not even gonna do it. So it's a quarter turn. It's gonna move 1 quadrant. Every 90 degrees is 1 quadrant. So the shape's gonna move over to here, but it's gonna rotate. All right? The easiest way to rotate is just for me to do it and then kind of explain it after. Grab this point, this 3, 3, and instead of being here 3, 3, it's gonna be here negative 3, 3. All right? And now, imagine this shape right here falling down and rotating. Instead of facing up, it's going to face out, all right? Instead of facing up, it's going to face out. So instead of being 6 blocks up, it's going to be 1, 2, 3, 4, 5, 6 blocks out. Instead of being 3 blocks flat, that 3 blocks will now go up. And can you see, 2, 3, sorry, 1, 2, 3. Can you see that we've got the same shape, and I'm not even going to label all the coordinates because it's not important right this second. We've got the same shape, but it's been rotated, it's been spun, all right? Let's keep spinning it, all right? Let's rotate it another 90 degrees, which would have been 180 degrees in the first place, right? If we rotate another 90 degrees, again, this dot, instead of being 3, 3, is going to be 3, 3 here, all right? That dot almost doesn't change. It just moves locations a little bit. And now, instead of facing out, it's going to face down. Instead of facing out, it's going to face down. So those 6 blocks go 1, 2, 3, 4, 5, 6. And instead of being up, that's going to be over. 1, 2, 3. And can you see again that that shape got, that's not a great triangle, but you can bear with me, got rotated. I hope you can see it. All right. So again, this was a 90-degree rotation. But this, if I'd gone from here all the way to here, would have been a 180-degree rotation. 180 degrees means to turn around and face the other way. All right? So now instead of facing up, the triangle faces down. Let's rotate one more. There's one more type of rotation we need to do, and it's to rotate all the way around to here, and that would be 270 degrees. Okay? Real easy. That 3, 3, instead of being 3, 3, is going to be 3, 3. All right? It's all 3s and 3s. Okay? Notice that corner makes kind of a square with itself. I hope you can see it. All right? Those corners make a square with itself. And now, instead of that shape, let's go 270. Instead of that shape facing down, it's going to face over. All right? So the 6 blocks go 1, 2, 3, 4, 5, 6. And this, instead of facing over, as I spin it around 270, it's going to face down. 1, 2, 3. This is hard to see. Once you get to 270, it gets tricky. All right? That's okay. But again, notice the triangle was facing up, now it's facing out, now it's facing down, now it's facing over the other way. And this is a 270-degree rotation. Wow, that's confusing. It's okay if you're a little bewildered right this moment, okay? We'll work through it. 90 degrees went one quadrant, 180 degrees went 2 quadrants, and 270 degrees went 3 quadrants. So, and you know the answer to this already. What happens if I rotate it 360 degrees? Well, it gets right back where it started, right? I don't even have to draw that, because you know if you spin around in a circle, you're back where you started. If the hand's at 12 o'clock and it goes all the way around 360 degrees, it's back where it started. So, last thing to say here, and this is just for those of you that are interested in extra information, we have been going counterclockwise right here. All right? And what that means is we've been going against the hands of a clock. Clock hands go this way. We've been going this way. It's called counterclockwise. We could also have rotated this way from the beginning. All right? And what I hope you can see right now is that rotating 270 degrees this way, counterclockwise, would have been the same as rotating 90 degrees clockwise. All right? So rotating 270 degrees the long way around, counterclockwise, well, we could have gotten there quicker by rotating 90 degrees clockwise. All right? It's no big deal if you're not quite following everything. What is important, if we can bring it back, is that I hope you can see that this shape doesn't change size. It just changes direction. All right? It's the same triangle every time. It just changes the way it looks. And this is called a rotation. All right, y'all. That's it. No big deal. You got to go try to do your dilation and your rotation. Good luck.